He gets tired sometimes. Keep working. All right, so this would be what I would call, this looks pretty uniform. I would call this a uniform distribution. It's uniformly distributed amongst all the stems. Does that make sense? If you made a stem and leaf flop, if you made a stem and leaf flop and you stopped here, I would have to take points off. So here's what's missing. What's missing is telling me what the hell this means. So you'd say 1, 2 means 12. Because what could 1, 2 mean? It could mean 1.2. It could mean 102. Because maybe my stems are hundreds and my leaves are single digits. So 102, 108, 202, 205. Do you guys see the flexibility built in? So this, by itself, could mean a lot of different things. So you have to give me a key. A way to read this. Please, dear God, don't do like a student did a few years ago and do this for every single thing. You're kind of defeating the purpose then, right? 1-8 means 18. 1-7 means 17. No, don't. Just do it once. You just do it once, and then I can do the rest. Yes?
So without a key, our stem and leaf flies incomplete, right?
Exactly. So you'd lose a point or two, depending on how many points that problem's worth. Cool. I like it. All right, good. So let's see what the calculator can do for this. Did I just turn that off? Yeah. No, I don't want you to power off. I want you to wake up. Okay. So, since my computer is not an Android phone, we have a built-in TI emulator. No, register later. Oops. Okay, alright. Bam! Okay. So what do you think is the most important button on here for our class?
Oh, the off and out button.
I like it. I always like to leave open-ended questions because I want to see who my smart asses are.
The second button?
Second button's important because you have to get up to some of that stuff, but stat button's probably very important. How many of you guys have never used a TI calculator before? So real quick, so most of you have, that's good. If you've gone through our 110 here, you should have. But real quick, it's like a scientific calculator, which is much better than those 4-function calculators, where you got plus, minus, times, divided by, and that's it. And when you do that, you go 7 times 5, and the 7's gone. Minus, parentheses, and if you got to get parentheses in, screw that. Forget about it. Okay. So here, if you had to do 8 minus, parentheses, 9 plus 6 to the third power, you can see the whole thing, right? You hit enter. Yay. Now, do you see how my to the button is a little caret? Some of you guys have a newer calculator where it actually puts the cursor up in the power. Do you guys know what I'm saying? Does anybody have a newer calculator? Like hit your square root button. Second, see x squared? So it's a good point. Second is very important. Second, x squared gives you the square root button. How many of you guys had a parenthesis open up? Anybody not have a parenthesis open up? There you go. So start typing. 7, 9, 8. Is your square root button getting bigger? No. Oh. You need one of those two things. Oh, the poor little thing. Let's see. So you do have one of them. So second. And then watch how see how your square root button just gets bigger? So we're all jealous of you. So the newer version of the operating software for these, like the square root button just kind of goes across so you can actually see what's in the square root. Now if I put a parenthesis and put times 6, is the 6 in the square root? No, because I close a parenthesis, so it's no longer in the square root. You guys with me? Whereas you can actually just see the square root symbol that it go all the way across. It's much easier in the newer one, so I'm very jealous. Plus yours is really nice and thin. That's awesome. These things are like fat. All right, that's a really new one. All right. Enter. So then you get that. So everybody do that so we all have the same number up there. Square root of 798 parentheses times 6. Alright, so everybody with me that's playing along? Yes, ma'am. Oh, no, so here's the thing. So you got a new one too. So when you do square root 798, if you want to come out of there, you hit over. And now you're out of it. So now, cool. How are we doing? Is everybody alright? Okay. Now, do this. If I wanted to take the square root of that answer, I could do this. Instead of having to retype the whole damn thing, one of the other most important buttons on this is the A and S. Down here, see this? What am I doing? What are you doing, Jeff? Oh, is it not here? Oh, well, too bad for me. I always like to play with my laser. I've got a laser. Where's the button for it? You don't have the button. Why don't you and the laser do it? Oh, too bad. So down here is the A and S button. It's temporary memory. So if I hit second, negative, it'll be the A and S. And that's the square root of the last thing that showed up on the screen. That is remarkably useful. So that's the easiest memory location is A and S. So now what's in A and S? 13.0 and blah, 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 blah. Right, so I don't have to type the whole damn thing out again if I need to do something. Now, if you just hit the plus key right now, it'll actually automatically assume you mean take what you just got and add something to it. That's also nice. But unfortunately, there's no scroll. What if you have to go back up here? What if you're supposed to put a 5 there instead of a 6? Well, then you retype the damn thing. But let's just pretend like it's a really long thing. If you hit second, enter, second, enter, second, enter. I think with the newer ones, you can just hit the up arrow, and you can go back through your previous stuff. Is that true? Yeah, look at you with the, yeah. And then you can just go back and edit. So if you had some really long ass, and we will have very long equations in here, and it so desperately sucks. You get to the end, enter. Oh, that was supposed to be a 3. Shit. You just hit second, enter, and you can go back and make it a 3. You don't have to retype the whole damn thing in there. All the parentheses and all this shit, right? Okay, maybe. Okay, so enough of that. Let's do some stats. So, hit the stat button. Bam. So when you want to input data into the calculator, you use edit. And now, depending on if you borrowed a calculator from me, let's see what happens. You never know what students have done with them. Let's see. So my lists look like that. So stat, edit, right? Is everybody at this point? Do some of your lists have stuff in them?
Yeah.
Okay, so let's take care of that first. Now notice this. This is when people start to freak out. If you go up to L1 and hit clear, enter, it'll be clear. Right? This house is clean. Now if you go to L2 if you hit delete, that's when you lose a list. And that's when students freak out. There is no list 2 anymore. You have I have killed it. I feel horrible. So if that ever happens, or if you borrow a calculator and there's like L1, L2, and this one is called Fred, you hit stat, setup editor. Bam. And by the way, if you are desperately taking notes or something, or just trying to remember everything I'm saying, don't forget, everything I'm saying is on your calculator Bible. That's available on the website for a nominal fee. No, for free. All right. So let's get back into our list. So just go ahead and clear the first 3 lists. Let me know if you have some trouble. Oh, 2 stat, number 5. Edit. Now hit stat. Edit. So any free keys. Stat up editor takes you back to L1. Sure. All right, let's put this data in. Put that data in. So all you do is start typing 12, enter, 18, enter. You don't have to sound like Matt Quinn down Springfield. See, this is the exciting part of statistics. Data entry. You too could have an exciting data entry position.
So I'm putting all of the numbers up there?
Yep. All into list 1. Alright, how are we doing? So when you get done typing them in, the last blank spot should be the 17th spot because there's 16 numbers.
What if I inputted a wrong number on the list? How do I clear that one number?
Yeah, just hit clear. That should work.
Okay. Like highlight it?
Yeah, or just start typing over that. Hit clear. Try hit clear. Bam. And now just type in the right thing. Don't worry. Yeah.
So it has to be okay.
Alright. Where are we all at? Are we good? The suckiest thing in the world is if I give you 38 numbers and you get to the end and it's 37. Shit. Which one did I leave out? That sucks. That sucks big time. So make sure, do that check at least. Make sure you got them all in. Now let's sort this list. Oh, sorry.
We can't figure out how to put it in.
Oh, yeah. No. You went up to stat plot, I think, right? So it's just stat edit. Yeah. Cool. Sure. All right. All right, so here we go. If you hit the stat key, which one of these looks like the one I want? There's 2 maybe. Sort. Now, what do you think the A and D mean?
Alphabetical.
Ascending and descending. Cool. So let's do it ascending from smallest to biggest. So pick the sort A, the sorta button. Now notice how it's got a parenthesis like a function. So you have to tell it which list to do. Do you see above the number 1 key? What's above the number 1 key?
L1.
Crazy. So you hit second, 1, and then so you're telling it to sort in ascending order the stuff in L1. We stop there for a second. How are we doing, everybody? I am. All right. Enter. That was kind of anticlimactic. And then done. So if you go back into your list, stat, edit, now it's in order. Woohoo! Yippee! All right.
Wait, which one?
Let's see. So you go to stat, sort A. So you need to hit the number 2 or scroll down and hit enter. I don't care. And then you tell it. So is that cool? Sort A. You see that? So if you hit stat, sort A, and then you tell it, oops, I got it in there twice. Tell it second 1. Tell it to sort list 1. Enter. And now if you go back, stat, edit, your list is in order. All right, and that's very useful when you have like 52 data points. You don't want to necessarily do that by hand. All right, you guys still kind of with me?
Yep.
Roughly? Okay. All right. Here's the next level. Let me show you an example of my goal for right now, where I want us to get to. Here we go. Perfect. This is the kind of image I want us to get to. This one right here. Oh crap, Jeff. Dadgummit. That was exciting. No, there's input. Input. What do you mean there's no input? Oh. Now we gotta wait for it to work. Alright. How old am I? 80. Oh my. So all this technology. So you don't know what data this came from. Somebody tell me something from this picture. What do you think that word frequency, how it relates to the size of the bars here? What do you think that has to do? Maybe this is the number of books that some kids read over the summer. Let's pretend, right? You guys kind of with me?
Like frequency is in like hertz?
Not really, but it's sort of related because hertz, of course, is the number of times per second something happens. So the frequency here is the number of people in each. So how many kids read basically like 3 books, something like between 2.5 and 3.5? 16. You with me? So we're getting to the point. Whoa. We're getting to the point where we create this kind of picture for ourselves. This picture is what's called a histogram. A bar graph normally has like Chevy, Buick, blah, 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 and the heights mean the same thing, but that's qualitative data. Histograms are related to quantitative because see how a scale, there's an actual scale. Whereas I don't have like Chevy and Buick and you're worried about scale. What? No, they're just names so they can go wherever the hell they want to. I guess still kind of with me. So that's the goal. I want to take this data and make that kind of picture out of it. So what was the highest data point in this set of data?
45.
Say again? Careful. No. That was the most that were a certain data value. Right? That was the most. But this is the data, isn't it? That's the number of each data point. What's the highest data point?
6.5.
Yeah, at most 6.5. None of the data could have been 6.5, but this means that there were 2 things between 5.5 and 6.5, right? Maybe the kid almost finished a book, 5 books, so it's 5.8 books. So he's in there. You with me? And somebody else did 6.2 books. So they're in there. You guys understand? Okay, good. At least those of you who want to humor me are like, sure, man. All right. So, notice the key thing here. Are there a lot of repeats up here? Just 1, really, or 2, man. I don't know, somewhere. Oh, here, yeah, 39. If there were like a ton of repeats, I could just have 10, 11, 12, and maybe there's 8 10s and 3 12s. I wouldn't have to worry about this. Notice what's going on here. This is a range of data values, right? So how many rectangles are up here?
6.
6. And how far, what's the range here? 6, right? And sure enough, how wide is each rectangle?
1.
Does all the math of what you just said make sense?
Yes.
If I want to go 6 and I want to use 6 things, they each have to be 1 big. So how far do we need to cover? How far does our data range?
From 1 to 45.
So how big is that range?
33.
Yeah, so you did high minus low. So we got to go 33. Let's try to be 3. You're still trying to be 3. Okay, 33. Right? So we want to go 33. And let's use 6. Normally you use between 5 and 10 classes. These are all called classes. Every rectangle is a class. So you normally use between 5 to 10 classes. So let's use 6 also. So how do I figure out? This math is very physical, actually. If you wanted to tile, if you wanted to put wood paneling on that wall, and let's say it's 20 feet across, and I wanted to use 10 panels, how wide would each panel have to be to cover it? 2. How far I want to go divided by how many I wanted to use, right? So I know how far I want to go. Let's use 6 classes. I know how many I want to use. How wide does each one have to be? How would you figure that out? Divide. 33 divided by 6 so that I know I cover all the way across. You guys, does that make physical sense? That math, that's math that makes physical sense. Holy shit.
So would you want kind of like put 5 so it's 35 just so it's kind of over, or do you want exactly the length of 35?
You never go under, you always go over. So if I wanted to cover that wall with wood paneling and I made my panels a little less wide than they're supposed to be, they wouldn't cover it all the way, would they? So you can over cover is what you need. All the data points have to have a place to go, right? So what is 33? So this is what's called the class width. That only makes sense. It's how wide each class is. So we called it the class width after several days of debate. So how do I get the class width? I take how far I've got to go, divided by how many I want to use. And that comes out to be exactly what? Good. And so we never, let's not do this. We always round up to the next nice number, next whole number. 6. Cool. So I know I want each class to be a width of 6. All right, cool. Some of you guys should be pretty decent with math and know that from the 6 times 6 was 36. I knew 6 already, Jeff. Well, that's good. This is what you do if you're not really sure how to do the math. Bam. That's the formula you use. I've got a handout that's got this on it too, so you're good there. You should probably be looking that way. That's my fault. Get up there. Stop it. All right. So let me see. Yeah, let's take 2 more. That's fine. All right. So let me get us started here, and let me show you. I don't necessarily agree with the way the book does this. I'm just going to show you my way, the way I was taught. I usually show 2 different ways, but screw that. Let me just show you the better way. All right. This is not better because I was taught it. It's better because it's better. So what's the lowest data value? 12. And I want my classes to be have a width of 6. The only problem with this way is, well, screw it. You guys are supposed to know algebra. You ready? So I want all the data values. So x represents, x is the same x as always. It represents all these at once. So I want all the values that are between 12 and 18. You notice, be very specific here. I'm going to talk about why here in a second. And the book is actually not, this is one thing about the book I've noticed so far, is it's not really clear on this. So the next class is going to go from 18 up to 24, because they're all 6 wide. Do you see why I've got to do this? If I didn't do that, if I just said it's up, if I just went 12 to 18 and 18 to 24, where the hell does 18 go? In the first and second? That's not fair. Why count 18 twice? So in this case, where does 18 go? Which class?
The first one.
Sorry, I'm sorry. That wasn't there. Where does 18 go? The second one, because the first one is less than 18. Right? And the reason this is so beautiful, if you read through the book, they're all worried about, is it decimal data? Well, where would 17.924 go?
The first one.
In the first one, there's no question. You kind of with me? Yeah. A little tiny bit? Okay. All right. And so let's finish this out. So the next one will go from 24 up to 30. And then from 30 up to 36. And then from 36 up to 42. And then from 42 up to 48. Cool. And that covers everybody, right? You with me? If there was a 48 in my data, I would be allowed to do this. That's the one time I would be allowed to do that. Just suck that 48 into the last set. You with me? Because how many classes do I have written up here?
6.
Good. That's how many I wanted, right? So I wouldn't want to make it a whole other class just for that one little data point. Okay, maybe you guys are with me. Okay. All right. So this is my classes. What time is it? Oh, shit. And then I want frequency. So now I've got, Jeff, here we go. Okay. All right. So here's where people get a little freaked out. I'll get somebody that does this. Why are they putting 6s everywhere? Because there's 6 things in. No, there's not. How many things? How many data points are in here? Be careful. Am I counting 18?
2.
Yeah, good. There's only 2, 12 and 17. So there's 2 things. How frequently does something show up in this class? Twice. 18 to 24. 3. The look in your face. You're like, 3. What the hell, man? I love that. Like, can't you count? No, no, I just make this shit up every day.
2.
Yeah, so 24 to 30, there's 25, 25, and 28. So there's 3 there.
You would even count the repeating numbers, right?
Totally. Because that might represent 2 different people. I don't want to throw somebody out. Now we get something interesting between 28 and 36. The next class is 30 to 36. Is there anybody? There's nobody there, so that's 0. 36 to 42.
4.
7, is there another? 7, I think, right? There's no other 42 yet.
Wait, well, we don't count 46.
Not 42, good. So 6, and then 42 to 48, 2. And then what you do real quick is you make sure, this is 5, 8, 10, 16. Good, thank God. You want that to equal the total number of data points, right? It always sucks when you add these up and you get 15 or something. Oh shit, who did it leave out?
So you add repeats? Like if, since 25, you count it twice.
Exactly, because this represents, in this case, it could be people's ages. And I don't want to throw Bob out just because he's as old as Fred. I want them both to be up there.
So those numbers for the frequency, or how many numbers are within that one?
Exactly. There were 3 data points that fell between those 2 numbers,
Okay.
not including 24. Cool. I like it. Yes, ma'am.
Would there ever be a time where you don't count a repeat data point?
Not for this, no. No, in fact, in general, not, because they are 2 separate people or things. You have to represent both. Right, and really the thing I want to know is there anywhere that people seem to cluster? Is there anywhere that people seem to mostly be in? And if I don't count the repeats, that's going to totally change. You know, if there were 80 people that were 25 years old and I just count them once, holy shit, I'm going to totally change the distribution of my ages, and it's not going to look the way it's supposed to. The last thing, and then we're going to go on a field trip. I'm going to have to hold off on the whole creation of the picture here till next time. There's something called relative frequency. And that's a really kind of strange phrase. Anybody have any clue what that might mean? So this is absolute frequency. And this is kind of related to, if you saw a study and they said, here are the number of people who are in prison in California. But look, here are the number of people who are in prison in Rhode Island. California is just nothing but freaking criminals and perverts and shit. Right? What's wrong with that comparison? Yeah, there's so many freaking more people in California. But you'd be surprised at how often this type of thing happens. And people are, oh my God, you got to make them into what to compare them? Ratios, percentages. So relative frequency is another name for percentage. Relative to the total, how many are in this class? So the total was 16. So what's the relative frequency here? 2 out of 16, which is
1/8.
1/8, which is 12.5%. You do 1 divided by 8.125. You guys with me? Go ahead and make it into a percentage. So then this will be 3/16, which will be, I don't know, 0.6. Is that? I don't know. I'm not going to try. Yeah, 13.1, isn't it? No. 18. Don't try it, Jeff. 18 point. Somebody help me out. 1/4. Yeah, 18 point something, right?
0.8125.
Yeah. No, 8.125. Wait a minute.
So it'd be 8.125%.
No, 3 divided by 16.
Hold on.
What is it? Can nobody do that?
I accidentally did
0.8175.
Oh, thank you.
0.1875. That makes more sense. 18.75%. That doesn't sound right. Can somebody do 3 divided by 16? That's right? Okay.
Yeah.
And then that one, thank God we got that already. And 0 is 0%. That's crazy. And then 6 out of 16 will be twice as much as this, so that's 37.5%. And then 2 out of 16 we already know is 12.5%. What should all these add up to be?
100.
That's crazy. Now, of course, if you round it, it could add up to be 99 or 100 point something if you have to round. So it doesn't have to come out to exactly 100%. This is actually in, all of this, what we've done, is actually sort of in section 1.3. but then is used again in section 2.2 to make that shape, the histograms. So today we officially made it through 2.1. We haven't finished 2.2 yet. So do this favor for me. We're going to go on a field trip. Get all your stuff together. Go out the door and go in the direction of the tech mall just a little bit. And wait for me to run out there in front of you. Oh yeah, calculators. Bring them back up. Put them in my bag of calculators. Please don't take those calculators and make it your own. I don't make enough money to buy them. Please.
Like, for example, like, there's like, you just do this numbers, have to say, put them in classes, find a frequency.
Yes. And then you're going to make that picture, so next time we'll talk about how to make that picture.
Oh, like,
From what we got.
just the graph there?
Yeah.
That's good. And like, for the population thing that you're talking about, what's like the ratio of all the population in California and then to the ones that are in jail?
Yes.
And the same thing with Rhode Island?
Exactly. And then that will be a fair comparison. Yeah.
Thank you. Do you see the roster again?
No, normally I don't.
Okay.
Yeah.